As you have seen how the partial fraction is applicable in the integration, especially we think about this partial fraction in integration when we find the denominator can be factorized into more than two or more than two factors. Maybe the each factor in the denominator can be a linear factor, can be a quadratic factors. But first of all, we have to check it is a proper partial fraction or improper partial fraction, which has been explained before. So improper partial fraction means the denominator degree is less than the degree of the numerator, and the proper fraction is the degree of numerator is less than that of denominator. So first we are going to start with the exercise 8.10 of ML Agarwal sum number 1 part 1. Here it is given that look at the sum that integration x minus 1 by x minus 2 whole bracket x minus 3 dx. First we are going to expand, or rather we have to segregate the given irrational part p by q form into two fractional forms. So since the denominator, and first and before go into that, just check is an improper or the proper partial fraction. The degree of numerator is 1, whereas the degree of the denominator is 2, because if you expand this it will be a quadratic expression. So first, for that we are going to take the partial according to the rule explained, that the partial for this is to be what? This one. Since the denominator is with two non-repeated linear factors, so the partial would be what? A by x minus 2 plus b by x minus 3. Now we have to find the values of a and b. If you take LCM in the right hand side, then it would be in the form of a into x minus 3 plus b into x minus 2. So both the denominators gets cancelled. Therefore, the given expression of the numerator x minus 1 can be written as a times x minus 3 plus b times of x minus 2. Now this is not an equation. This is an identity where it will be satisfied for different values of a and b. So if you put x as 2 in this expression, what we get is this part is 0. Alright. In the left hand side, by putting x equal to 2, it's a 2 minus 1 is equal to a times 2 minus 3. So we get the a value as minus of 1. Similarly, if you put the b value, then what as x value as 3 will get the b value. So if you put x as 3, x as 2, then what we get? We are going to get that x is equal to, we are going to put 2. So 2 minus 1 is equal to, no, just make a correction that when you put x equal to 2, we are getting the a value as minus 1. That was fine. Now to find the b value, we'll put the x value as 3. So if you put x as 3, we get what? We get, by putting x equal to 3, we get 3 minus 1 is equal to 0 plus b. So b would be 2. Now we will be substituting the values of a and b here. So the given integration turns to minus 1 by x minus 2 dx plus 2 by x minus 3 dx. So after integration, what we get is, the integration of this is log of x minus 2 and the integration of x minus 3 is log of x minus 3. So this would be the answer of the given expression. Now we'll be solving sum number 2 part 2. Here what we find, that the degree of numerator is 2 and the degree of the denominator is also 2. So we have to do something to bring it into the improper partial fraction. So what are we going to do? See, just have a look in sum number 2, that we need to divide the numerator with the denominator. That is the long division which you have done earlier in class maybe 8 and 7. So practically we have to divide x square plus 1 by the value of the denominator x square plus 5x, not 5, plus 5x, the minus 5x plus 6. So if you divide it by this, so it will be 1 times x square plus 6 minus 5x. Now you subtract, you will be getting what? If you subtract, it is coming to plus 5x and minus 5. Alright, so plus 5x minus of 5. Now this expression can be then written as 1 whole, this line, 5x minus 5 by x square minus 5x plus c. So ultimately this improper partial fraction to be converted into the proper partial fraction. Then we can go by those 4 rules, whichever is suitable for this particular equation. So that is what about done. Next is what? Now we have to take the partial fraction for this part. That means what? We are going to leave the plus 5, x minus 1 by x minus 2 and x minus 3. Like the last sum, the denominator contains 2 non-repeated factors. Therefore, we will be taking the partial as a by x minus 2 plus b by x minus 3. So multiplying both sides of the equation by x minus 2 and x minus 3, we get this expression. So like the last sum, put the values of x as 2 and x as 3 successively in this expression. We are going to get the a value as minus 1 and the b value is 2. But don't think because in the last sum also I find we have got the AB as the same answer. Don't think that every time we are going to get the same answer. That is not. AB value would be different. Now come back to this integration. Which integration? We are going to come back to the integration, this one. Alright, or rather in this one. So the first part of the integration of 1 is x, and the second part integration would be, let's see what it is to be. So the second part integration is turned to then minus of dx by x minus 2, which is to be log of x minus 2, and the other part would be 2 by x minus 3. That means log of x minus 3. Thus the given integration is equal to, I had a x before, and this is the value of the I1 and plus c is must. Now look at the integration 7 part 2, which is given as this one, 4 by x minus 2. That means one linear factor, the other one is a quadratic factor. So we'll be taking the partial accordingly, and at the same time this is a proper partial fraction because the degree of numerator is 0, degree of denominator is to be, if you expand, the degree of denominator is coming to 3. So this is the proper partial fraction only. So from straightway from the given expression we can take the partial. 1 is coming to a by 1 minus x plus bx plus c by 1 plus x square. Alright. This would be the partial for the quadratic expression. For linear, as we have done before, it will be just a single constant value a, and for the quadratic the partial would be bx plus c. Now we are multiplying both sides by 1 minus x into 1 plus x square, or rather you take LCM. This is the line we are going to get. Now if we put x as 1, we'll get the value of a as 1. Now we are going to expand this one and to write according to the coefficient of x square x and without x. So let's see, if I write it, it is coming, the right hand side is coming to a plus ax square plus bx plus c minus bx square minus cx. So the coefficient of x square is to be what? A minus of b. But left hand side do not have any term containing x square. So that is a minus b should be 0. Equating the coefficient of x square, what we get is a minus b is equal to 0. So a is equal to b. From here we get a is equal to b. Since the a value is 1, so b value should be 1 as well. Now equating the coefficient of x, the expression which I had written from there, if you check that the coefficient of x square in the right hand side is coming to b minus c, but the left hand side do not contain any x term, so it is to be then 0. So b minus c is equal to 0, again is coming to c is equal to b, that is equal to 1. So we have got the values of a, b, c. Go back to the integration. Let's see what we get. So we are getting this part, that dx upon 1 minus x, whose integration will be this one, log of 1 minus x mod upon minus 1, and this part can be written as this way, 2x by x square plus 1 dx and dx by 1 plus x square, and the integration of this part is tan inverse of x. So we could manage the integration of the first and the last part very easily, but for the integration of the second part we have to substitute x square plus 1 is equal to z, which is not shown here. 2x dx is dz. Alright, so this integration then turns to, what? Half integration dz by z, which is to be, half is remain log of x square plus 1. So let's check the final answer once more. So this would be the line of answer, and plus c must be added with all indefinite integrals.